Hello, my name is Yong Kang Hao. Then today we will present about the problem-based learning project. Okay, so our group project is about series and sequence. Sequence is numerical circles and geometry circles. So our group member have Ahmad Zainuddin binti Amzi, Derwin Yong Solomon, Shari Nizam bin Khadis Fadila, Tan Ning Seng, and me, Yong Kang Hao. Okay, thank you. Hello, my name is Yong Kang Hao, and I will discuss about the acknowledgement. First of all, thank you so much for your continuous support and preserve whenever needed. We would also like to thank Miss Rabial binti Adam for her advice and contribution to the project and the preparation of this report. Last but not the least, we would like to thank everyone who involved in the project directly or indirectly. Thank you.
Introduction. Series and sequence are fundamentals in arithmetic. This means that they are the basics in order to understand arithmetic. A sequence is a collection of items or objects that have been arranged in a specific order. Meanwhile, series is the sum of all the terms in a sequence in the presence of a definite relationship between all of the terms of the sequence. Series and sequence is important for us to understand the pattern and progression of numbers and items, because it will help us to form a formula that can identify a certain turn of a term in a sequence. Arithmetic and geometric are sequences that follows the pattern of an object or events. The only thing that differs between arithmetic and geometric is that arithmetic sequence uses a constant difference, which means it only includes the addition or subtraction operation between each consecutive term. Meanwhile, geometric sequence uses constant factor, which means it only includes multiplication or division operation between each consecutive term. Definition. The definition for series is the sum of all the terms in a sequence. The definition for the sequence is a series of things or a set of numbers that are arranged in a specific order and according to a set of rules. Definition for arithmetic sequence is a list of numbers in which each new term forms a preceding term by a constant quantity. The definition for geometric sequence is a set of numbers wherein each element after the first is obtained by multiplying the preceding number by a constant factor.
Alright, so firstly is the problem statement. Part A. According to the first video link provided by the lecturer, the first video is about a female worker who wants to find a job after graduating. The female worker receives an offer from a company which offers her 55,000 rupees per month as her initial salary. The company also promised to increase her salary by 5,000 rupees for each year she worked at the company as the annual increment. She wants to know in which year will her salary reach 1 lakh rupee or 100,000 rupees per month. The concept introduced by the video is arithmetic progression, which is what the female worker needs to do to know when her salary will reach 1 lakh rupees. From the video concept, we can create our own question and learn more about arithmetic progression. Alright, so problem statement part B. Besides that, according to the second video link supplied by the lecturer, the second video is about how the bacteria is so small. A pinpoint of a needle can fit about 500,000 of bacteria. In fact, only 1,000 of disease-causing bacteria is enough to make a healthy individual to become sick. As such, the amount of disease-causing bacteria on a pinpoint is enough to make 500 people to become sick, and 500,000 divided by 1,000 is 500. Bacteria can also reproduce by splitting in half, thus aggravating the said problem. So, the speaker of the video wants us to imagine that there is initially 5 bacteria, with each bacteria reproducing every 15 minutes. After 1 hour, there is 80 bacteria, and so on. So, from the video, we can derive the algebraic formula of geometric progression. From the video concept, we managed to create a question regarding geometric progression. Alright, so this is the question we have created. So the first question is Ahmad loves collecting stamps. He started a new collection of stamps, number about 125 stamps initially. For each following week, Ahmad's stamp collection increased by 15 stamps. How many stamps will he collect by the end of week 12? Alright, so second question. Young brought a Proton Saga car for 1,230,000 ringgit. After each year, the value of the car will depreciate. The chart below shows how Yong's car will depreciate over the years. If Yong wants to sell the car by the 9th year, how much money will he get?
Hello, my name is Delvin Yong. I will present about the filler table regarding the first question as previously mentioned by Tamin Cheng. The facts we can get from the first question is Ahmad started a new collection of stamps numbered about 125 stamps initially. The next fact is for each following week, Ahmad's stamp collection increased by 15 stamps. The ideas we can get from this question is Ahmad loves collecting many different types of stamps. Ahmad also love have a lot of stamps by the end of week 12, let alone after week 12. Learning issues we can get from this question is how many stamps will be collected by the end of week 12. Will either arithmetic or geometry progression will solve this problem. Resources we can get is internet, talk, and article. As for the second question, the facts for the second question is Young bought a Protosaga car for 1,230,000 ringgit. And the second fact is at the end of each year, the value of the car will depreciate. After that, after the first year, the market value of the car reduces to 1,143,900. After the second year, the market value of the car reduces to 1,063,827. The ideas we can get is Young's car has undergone some body damages and accident history. This decreases the car's market value over time. The learning issues we can get is what is the certainty that the market value of the car will be 6 digits value by the 9th year. After that, how much money will he get by the 9th year? Will either arithmetic or geometry progression solve this problem? Resources we need is internet, talk, article, and economic stock market statistics.
Okay, next I will present about the solution of variable about the both of question that has been stated on the front of the video at the at the above slide. And there were two questions. And first, the first question is about arithmetic progression, and the second question is about the geometric progression. As we can see, the formula for the arithmetic progression is using the Tn equal to a plus n minus 1 d. And in the question one, in the part A question one, we can see that Ahmad loves collecting stamp, and it stated about Ahmad initially collect about 125 stamps. The 125 stamps is initially, and we can label is as A in the formula, which is the first initial, the first thing. Okay, next, and it stated that Ahmad collect increase 15 stamps each week. So the 15 stamps is the D, the different between every week. And we just basically we just need to put the value in the formula, which is we put as the Tn, and n is the value for the week that we want to calculate, which is we want to calculate the end of the week of 12. So we put the n equal to 12 and a equal to 105 and d equal to 15. So as I stated in the slide, t12 equal to 135 plus 12 minus 1 times 15, and we get 290. That is the stems, the value of the stems in week 12 that Ahmad. Okay, next is the question 2, which is the geometric progression question. And in this question, it wanted to know the value of the young sell the car by the 9th year. And it also stated the initial price of the young car is 1,230,000. And we just use the formula Tn equal to ARn, AR the power of n minus 1. And the n value is the 9, and the ratio we need to find the ratio, which is we divide the second year and the first year, and we can get the ratio, which is 0.93, and we just put the value in the formula. We just put the value and we can find, and I found it 688 and 285.63 cent. That is the value of the young car in the 9th year. So that's all from me. Thank you.
So the discussion part for the question 1 is, the initial amount of stamps Ahmad had at first is 125 stamps. His collection increased by 15 stamps for each following week. We are required to add 15 stamps for each following week, and so on until we reach week 12. As such, we know that this problem needs to be solved with arithmetic progression. His stamp collection number about 290 stamps by week 12. Alright, so this is the discussion for question 2. Young bought a Protosaga car for 9,230,000 ringgit initially. During the next year, Young's car has its market value depreciated to 1,143,900 ringgit. During the third year, Young's car has its market value depreciated to 1,063,827 ringgit. So we can conclude that after each year, the value of Young's car depreciated by 7% of its original value, leaving away only 93% of the car's market value compared to the last year. As such, we can know that geometric progression is used to solve this problem. Then we learn that we have to multiply the car's market value by 0.93 starting from second year until we reach the 9th year. To conclude my points, Young will only get 688,285 ringgit and 63 cents if he sells the car by the 9th year. Alright, so conclusion. To encapsulate my points, the members of our group learn much regarding geometric progression and arithmetic progression. Arithmetic progression is used in situations where the difference between two consecutive values are always the same, while geometric progression is used in situations where ratios of two consecutive numbers are always the same. By working together to solve problems, we instill a sense of cooperation and trust among each other. We hope to learn much more about algebra and its application in daily life. Thus, this report comes to an end.